Hey y'all, it's me, Miss B, and today we're talking about polar graphing. We were introduced to polar graphing when we made our Valentine's Day cards, but now we're going to plot points ourselves. All right, so when we're polar graphing, we talk about them in terms of r and theta. So so we use r and theta instead of x and y. R is going to be our radius, where each circle is +1. So this will be 0, 1, 2 on that radius. And then theta is our angle. All right, when I'm graphing, I really like to start with theta, because these negative r's can kind of throw us off. So we're going to start with negative theta. And so I'm going to start at 0 and go to 45. So here is my line for 45. And then from the center, kind of keeping this in my focus, and I wouldn't draw all these, I wouldn't draw all these lines. It's just I'm drawing them for kind of visual effect. I'm going to go out to 3, so 1, 2, 3, and so that point right there is my graph. And so I'm going to erase all this other stuff. We don't need it. This right here is the point 345. All right, for my next one, I'm going to go to 315. So that's right here. So all the way around. Oh, wait, we're going negative 315, so I'm going this way instead. So I'm going all the way around. 315 brings me right here. Oh, gosh, why does it do that? Brings me to right... goodness, right here, this line again. So then I go 3 out, and again, it's that same point right there. So this is also negative 315. Next up, we'll do negative 3, 225. So I'm going to go to 225. That's this right here. And since I'm going negative 3, instead of moving in the same direction, I'm going to move in the opposite direction. So I'm actually moving this way for negative 3. So I'm moving, so this would be 1, 2, 3 if it were positive. But since I'm moving negative, I move in the exact opposite direction, which again is that same point. So this is negative 3, 225 degrees. Oh, didn't mean to do that. Then finally, we'll do one more. Negative 135 would take us to here. And then if we're going negative, we go the opposite way of that angle, which is right there. So all of these angles have the same ending point. So I'm going to say that these two are examples of why to do theta first, because those negatives move in the opposite direction. All right, so when we're negative, we're moving away from that angle measure. Okay, so all of these points over here, if you remember, are called coterminal angles. All right, so, all right, let's move on here. So we're also gonna have to write rectangular to polar. So if I have a point here, then this is my x and this is my y. Oh, yeah, y. And so my point is written like this, especially right? Actually, I'm not going to draw that. So that's my x and my y. The same point over here is measured by theta and this distance r. So that distance across here is r. So then that gives us r theta, and this gives us x, y. So we call these rectangular coordinates, and these polar coordinates. All right, so we're gonna go between rectangular and polar. Rectangular is x, y, and polar is our r theta. And so in order to do that, I'm gonna draw a picture. So I'm just gonna draw a triangle. So this is my x, and this is my y on my triangle. And then this is my r, and this is my theta. Okay, so in order to find r, what I'm going to do is I'm going to take x squared plus y squared. So this is just the Pythagorean theorem. All right, so r is equal to the square root of x squared plus y squared. To simplify that equation. And then just as before, theta, or tangent of theta, I should say, if you remember from 6.6, tangent of theta is going to be equal to our y over our x. So then theta is equal to the inverse tangent of y over x. Okay, so we need this equation here. Goodness. This equation here and this equation here. All right, then to go from polar to rectangular, let's talk a little bit about cosine and sine. Cosine is the adjacent over adjacent side over the hypotenuse. So that's going to be x over r. So here's x over r. So that is our theta. So cosine of theta is equal to x over r. And if we multiply both sides by r, x is equal to r cosine theta. Then sine is the opposite over the hypotenuse, which is y over r. So then sine of theta is equal to y over r. So then y is equal to r sine theta. Okay, so those are our formulas for the highlighted ones, are formulas for switching from rectangular to polar and polar to rectangular. Okay, so I'm gonna show an example of this. So here we have, this is our it just says recall because this is like our opening problems. Okay, so 345 looks like this. It's this angle. I'm actually going to go ahead and do a rough sketch of that down here just so we have it for reference. me a second here. All right, there we go. So then 345 would be about right here. Okay, so I'm gonna go ahead and make this slightly bigger. So we can see here to draw. So this is 345, where if I were to draw this out, this right here is 3. This angle right here is 45. So to blow that up, 40, oh, geez. 40, goodness. 45, and this is 3. So we are trying to find x and y. So we just use our equations. So again, just going to write out just to clarify, r is equal to 3 and theta is equal to 45. X is equal to r cosine theta, and y is equal to r sine theta. So it's just a plug and chug. X is equal to 3 cosine of 45, and y is equal to 3 sine of 45. We do want to simplify that. So when I simplify, cosine of 45 is equal to radical 2 over 2. So I get that x is equal to 3 radical 2 over 2. And y, again, sine is radical 2 over 2. So we get y is equal to 3 radical 2 over 2. So our rectangular coordinates are 3 radical 2 over 2, 3 radical 2 over 2. Gosh. So that is my answer there. All right, and that is all for today, folks.